Hi everybody, this is Hameeda Banu Begum, Associate Professor of Physics from Government First Grade College, KADUR. We start with the first problem. Calculate the intensity of the wave from a vibrator at frequency 70 Hz, which can send a wave of wavelength 3 meters and amplitude 5 centimeter along a string whose linear density is 2 gram per meter. To find the solution, we have to write the formula first. That is, I is equal to 2 pi square a square f square rho v. We know that v is equal to f lambda. Therefore, the formula becomes 2 pi square a square f square rho into f lambda. We have all the values. We will substitute the values here. Pi is equal to 3.142. A is equal to 5 into 10 raised to minus 2. F is 70 Hertz. And rho is 2 into 10 raised to minus 3 into lambda is 3. After simplification, we get I is equal to 101.6 Weber per meter square. Going to the second problem, a brass rod of length 3 meter is clamped at its center. It is made to vibrate longitudinally. Find the Young's modulus of brass if the density of brass is 8200 kg per meter cube and the frequency of the lowest note produced is 600 Hz. What is the solution? The formula is P is equal to root of Q by rho. For the fundamental mode of vibration, we know that L prime is equal to lambda by 4 and L prime is equal to L by 2. We know that P is equal to F lambda. So, F into lambda is 4L prime, that is equal to F into 4L by 2, that is equal to F into 2L. Now substituting the values for F and L. F is 600 Hz, L is 3 meters and rho is 8200. So after substitution and simplification, we get Q is equal to, that is Young's modulus Q is equal to 10.62 into 10 raised to 10 Newton per. Now we go to the third problem. Just calculate the value of surface temperature of the moon. Calculate the value of surface temperature of the moon. The values of Wein's constant and maximum emission are 2892 into 10 raised to minus 6 mK and 14.4 into 10 raised to minus 6 meter respectively. The formula is lambda maximum is equal to C by T. Therefore, T is equal to C by lambda maximum. We know that C is equal to 2892 10 raised to minus 6 divided by lambda maximum is 14.4 into 10 raised to minus 6. That gives rise to 200.83 Kelvin. So, we get T is equal to 200.83 Kelvin. Carnot engine with a cold body temperature 17 degrees Celsius has 50% efficiency. By how much should the temperature of its hot body be changed to increase the efficiency to 60%? Now what is the solution? Eta is equal to 1 minus T2 by T1. We know eta is 50%, that is 0.5. That is equal to 1 minus 290 by T1. Therefore, we get T1 is equal to 580 Kelvin. Now, eta prime is equal to 1 minus T2 by T1 prime. That is 0.6 is equal to 1 minus 290 by T1 prime. So, we get T1 prime is equal to 725 Kelvin. Now, what is asked? By how much should the temperature of its hot body be changed to increase the efficiency by 60%? So, increase in temperature delta T is equal to T1 prime minus T1, that is equal to 725 minus 580, that is equal to 145 Kelvin. Next problem. Calculate the RMS velocity of oxygen molecules at 27 degrees Celsius. Density of oxygen is at NTP is 1.43 kg per meter cube. Solution. We have to find the RMS values of oxygen at NTP and RMS velocity of oxygen at 27 degrees Celsius. So RMS velocity of oxygen at NTP is C is equal to root of P by rho. So that is 3 into 101.3 into 10 raised to 3 divided by 1.43. That's equal to 460.996 meter per second. The second step here is RMS velocity of oxygen at 27 degrees Celsius is C prime by C is equal to root of T prime by T. That is C prime is equal to C into root of T prime by T. We know we have found the value of C, that is 460.996 into square root of 300 by 273. So we get C prime is equal to 283.25 meter per. To the last problem, the critical temperature, pressure and volume of a gas are 33.1 Kelvin, 1.316 into 10 raised to 5 Newton per meter square and 6.56 into 10 raised to minus 5 meter cube per mole respectively. Calculate the van der Waals constants of the gas. What is the solution? We know that Vc is equal to 3b. From that we can find the value of B is equal to Vc by 3. Vc is already given. That is 6.56 into 10 raised to minus 5 divided by 3. We get B is equal to 2.186 into 10 raised to minus 5 meter cube. So we have found the value of B. Next we have to find the value of A. So the expression we are going to consider here is PC is equal to A by 27 B square. That is A is equal to 27 into B value is found already. That is 2.186 into 10 raised to minus 5 whole square into PC. That is given in the problem 1.316 into 10 raised to 5. After simplifying we get A is equal to 1.6979 into 10 raised to minus 3. So that is equal to 1.69 approximately can be written as 1.7 into 10 raised to minus 3 and the units. Okay, that is joule meter square per mole square. So that is the value of A. So with this we have completed 6 problems that have appeared in one of the question papers, old question papers.